we have to prove that there are two times for which the travels projectile travels the same vertical distance, the sum of this timings is equal to the total time of flight. There are two times for which the projectile travels the same vertical distance, the sum of these two timings is equal to the total time of flight of the projectile. In the diagram, we have a projectile of mass m which will be thrown from the point O, and OX is the ground or horizontal direction. The projectile describes this type of parabolic path. The projectile describes this type of parabolic path and strikes the ground at the point B. At the point B, u is the initial velocity with which the projectile was thrown, and the projectile strikes the ground at the point B with the velocity v prime. Theta is the angle subtended by the initial velocity u with the horizontal. A is the highest point. And at the point C and D, the projectile will have the same vertical displacement. When the projectile is at the point C, the projectile has the tangential velocity v double prime, and when the projectile is at the point D, the projectile will have the tangential velocity v triple prime. And at the point C and D, the projectile travels the same vertical distance or instantaneous height at the point C and D of the projectile will be same. We draw two normal Cn1 and Dn2 on the ground. At n1 time t is equal to small t1, and at n2 t is equal to small t2, and at the point B t is equal to capital T. At C and D the instantaneous heights are y1 and y2. Here y1 is equal to y2, and we have to prove that t1 plus t2 will be equal to capital T. T1 plus T2 will be equal to capital T. That is, height will be same, and sum of these timings will be equal to the total time of flight. Now, the instantaneous height attained by the projectile at the point C, y1 can be denoted by y. The instantaneous height of the projectile at instant t equal t second is y equal tan theta x minus half g x square divided by u square cos square theta. Y equal tan theta x minus half g x square divided by u square cos square theta, or comma y equal u sin theta t minus half gt square, or comma gt square minus 2u sin theta t plus 2y is equal 0. This is a quadratic equation of time t. The quadratic equation is gt square minus 2u sin theta t plus 2y equal 0. As it is quadratic equation, there will be two roots of time t. That means there will be two timings or two instant of time t1 and t2 at which the projectile attains the same instantaneous height. As t has a quadratic equation, that's why there will be two timings at which the projectile will have the same vertical displacement. Using Sridhar Acharya theorem, t will be equal minus of minus 2u sin theta plus minus, and here we have to use Sridharacharya theorem, that is, if ax square plus bx plus c is equal 0, then x will have the expression minus b plus minus root over b square minus 4ac divided by 2a. So here using this formula, here what we can write, under root minus 2u sin theta whole square minus 4g into minus 4g into 2y divided by 2g. Therefore t is equal to u sin theta plus minus 4u square sin square theta minus 8gy divided by 2g. 8gy divided by 2g. Therefore t is equal 2u sin theta plus minus 2 under root u square sin square theta minus 2gy divided by 2g. Therefore t is equal u sin theta plus minus root over u square sin square theta minus 2gy divided by g. That is the expression of general time. Small t. Now if we consider the diagram, in this diagram, as t2 greater than t1, that is the instant of time at which the projectile reaches to the point D, that is t2, is greater than the instant of time at which the projectile was at the point C, that is t1. That means as t2 greater than t1, that's why t2 is equal u sin theta plus root over u square sin square theta minus 2gy divided by g, and t1 is equal u sin theta minus root over u square sin square theta minus 2gy divided by g. Here t2 is greater than t1. That means instant of time at D is greater than the instant of time at the point C. At t is equal t1, y equal to y1, and at t equal t2, the instantaneous height y will be equal to y2. Here y2 is equal y1. That means the projectile attains the same height at instant t1 and t2 respectively. Now t1 plus t2 is equal u sin theta minus root over u square sin square theta minus 2gy divided by g plus u sin theta plus root over u square sin square theta minus 2gy u square sin square theta minus 2gy divided by g. And if we simplify, then we get what 2u sin theta divided by g, and t1 plus t2 will be 2u sin theta divided by g. That is, sum of these two timings t1 and t2 is equal 2u sin theta divided by g. Again, total time of flight in which the projectile is in air is the total time of flight of the projectile is given by capital T is equal to u sin theta divided by g. Capital T is equal to u sin theta divided by g. Therefore, we can say that capital T is equal T1 plus T2. Capital T is equal T1 plus T2. Hence proved. That means sum of these two timings at which the projectile attains the same instantaneous height will be equal to the total time of flight.